Hello everyone, welcome to MEP Booster. So in this lecture, we'll discuss electrical loads type. After the end of this lecture, you would be able to understand the types of electrical loads. So let's start. So first of all, here we are going to discuss about what is lighting load. So let's see. Lighting load refers to the electrical power consumed by lighting fixtures in a building or space. Okay. It is an essential part of total electrical load and is expressed in watt or kilowatt. Okay. So we have a different types of lighting fixture. All of you know LED down light, tube light, panel light, high bay light, street light, emergency lights. Okay. Different types of lights are available. So lighting load is what? Refers to the electrical power consumed by lighting fixtures in a building. Okay. So now here we'll show you the lighting load calculation methods. How to calculate the lighting loads. So in that, the first method, watt per square meter method, as per thumb rule, we'll see. Suppose here we have a building types. Okay. So as per thumb rule, you can see the watt per square meter value, load value is given in watt per square meter, but this is as per thumb rule, remember. Okay, suppose if it is a residential building, so for that how much lighting load? 5 to 10 watt per square meter as per thumb rule. For office, for hospitals, for classroom or school, for mall or retail shops, for warehouses, here the lighting load value is given in watt per square meter, correct? So here you can see the formula is also given. To calculate the lighting load in watt, first you need to calculate the area of that space in square meter into load density, watt per square meter. So for example, if I have a 100 square meter office, one office is of 100 square meter area. So to calculate the lighting load value, if you see, area into load density is given for offices 10 to 15. Suppose we have taken 12 average. So 100 square meter into 12 watt per square meter. So you will get the value in watt. Correct? So this is the watt per square meter method. Rule of thumb for to calculate the lighting load. Okay. Now the second method is fixture count method. Okay. So here what you need to do. Suppose if you know the number of lighting fixture and their wattage, so you can use the fixture count method. Okay. Formula is what? To calculate the lighting load in watt is equal to number of fixture into wattage per fixture. Okay. For example, if you have 10 LED panel of 36 watt each. So to calculate the total load, 10 into 36, 360 watt or 0.36 kilowatt. Okay. So in this way, you need to calculate the lighting load by fixture count method. But remember, for that you need to know about the number of lighting fixture and their wattage. Then only this method is possible. Now we'll see what is power load. Okay, so up to here we have discussed about the lighting load. Now we'll see about the power load. So see, power load also called as a receptacle load or socket load. So power load refers to the electrical power consumed by various electrical appliances and equipment plugs into the outlet. It is one of the major component of the total electrical load in any building. Okay, so we have a different types of power load. You can see different types. See, the load type is given here, like office equipment, PC, printer, scanner, monitor, their typical power rating is given. Okay, it is not fixed, it may be vary, but it is given the range. Same way if it is a kitchen appliances like microwave, toaster, induction stove, so for that power rating. So different types of power loads is given here. Now here the question is how to calculate the power load. So I will show you the methods of calculating power load. So in that, the first is by receptacle counts. Typical. Okay, so NEC or IS code allow us to estimate based on the number of outlets and type of room. Okay, so here the formula is given. Power load in watt is equal to number of outlets into assumed load per outlet. So for example, if you have 10 sockets in an office, so the total power load is how much? Suppose socket assume load per outlet is 180 volt ampere. So 10 into 180 volt, 1800 volt ampere. Okay, in this way you need to calculate. So this is the receptacle count method. Is it clear? Second, we have by actual appliances load. So more accurate, used for commercial and industrial project. Here the formula to calculate the power load by actual appliances load. So formula, summation of number of equipment into wattage. So for example, if we have a pantry room, in that one microwave of 1200 watt capacity, one kettle of 1500 watt and one fridge of 200 watt. So to calculate the total load, simple, the summation of number of equipment into wattage. See, 2.9 kilowatt we have got. Okay, so in this way we have to calculate the power load. It is very simple, correct? Yes, am I right? But remember, here you need to not all power outlets in your, if you have a large commercial space, so not all power outlet run at full load simultaneously. So demand factor are also used. Okay, if it is a residential application, demand factor 40 to 60% we have to consider. For office 60 to 80, for commercial kitchen 90 to 100%. And if it is an industrial workshop, so 100% normally. I will explain you about the demand factor, don't worry. Now we'll see what is HVAC load. Okay, so lighting load, power load we have discussed. Now the third types of electrical load is HVAC load. What is it? See, HVAC load refers to the electrical power consumed by heating, ventilation and air conditioning system, including chillers, air handling unit, fan coil unit, VRF or VRV system, exhaust and fresh air fan, pumps. Okay, so we have a different types of HVAC equipment and typical electrical load, you know that. Okay, so here how to calculate the HVAC load. So first, from HVAC equipment schedule, preferred method. So you get power input from HVAC designer or manufacturer. Okay, so formula is to calculate the total load, summation of number of equipment into power input in kilowatt. So for example, here you can see we have one chillers, 2 chill water pumps, 4 AHU, 4 exhaust fan. Each input power is given here. So first, easily you can calculate the total load, 146 kilowatt. So this is from equipment schedule, you can easily get. Okay, if you know the detail input power of chiller, which you will get from where? From the HVAC designer or from the manufacturer. Okay, they will provide you. So as per this, you can easily calculate the HVAC load. Now second, from tonnage of AC, simple. Sometime only ton of refrigeration is known. Formula to calculate the HVAC load, kilowatt is equal to TR into power factor. And we know that 1 TR is equal to near about 1.2 or 1.4 kilowatt. Okay, so here one example is given. Suppose for a 20 TR chiller, to calculate the load, 20 into 1.35. See, so 27 kilowatt. Okay, is it clear? Now we'll move to the next. What is mechanical equipment load? So it is given here clearly. If you see what is mechanical equipment load. So mechanical equipment load is what? Mechanical equipment load refers to the electrical power consumed by mechanical system that are not directly HVAC related. These include equipment for water supply, drainage, firefighting, elevator, escalator, pump and other machinery. Okay, so let's see, we have a different types of mechanical equipment. Okay, see, and power rating, equipment type, common use area is given and the typical power rating. Like if you have a water transfer pump for domestic water supply, so their power rating if you know, so it is very easy to calculate the. Okay, So here in this image, the types of mechanical equipment and power rating is given. Now we'll show you the methods of calculating the mechanical equipment load. So first thing, by using the manufacturer data to calculate the total load, simple, number of unit into power rating. So you need to use the manufacturer data. Okay. For example, here I have taken pump room. Okay. In pump room, suppose we have a transfer pump, 2 number of transfer pump, 2 booster pump, 1 fire pump and jockey pump. So rating of each transfer pump is 7.5. So the total load of transfer pump 15. So here if you see the total load which we have calculated, 65.2 kilowatt. Okay, simple. You need to use the manufacturer data to calculate the mechanical equipment load. And the second here, the demand or diversity factor. See, mechanical equipment load usually do not run simultaneously. You know that. So you need to apply the diversity. How much it is given? For water pumps, normally 70 to 80%. 70 to 80%. Now the last one which we need to see here, emergency load. What is it? Emergency load refers to the critical electrical system that much remains operational during a power outage or emergency condition to ensure safety, life support, evacuation and minimum functionality. Okay. So it is a power by backup systems such as diesel generator, UPS system or battery bank as per code like NEC, NFPA and local standard. Okay. So now we'll see the step by step how to calculate the emergency load. So what are the steps? First thing what you need to do, first of all you need to, if you want to calculate the emergency load, you need to list all emergency equipment. Okay, this is the first step. Second step, each load power rating. Note down each load's power rating in kilowatt or in kilovolt ampere. Correct. Then you need to apply diversity if applicable. And then add a safety margin 10 to 20%. Clear? Now here we'll take one example. Suppose we need to calculate the emergency load for hospital. Okay. Suppose here the load description is given, fire pumps emergency light. So 1 fire pumps, 50 numbers of emergency light, each power rating is given in kilowatt. So as I told you, the first step is to list all emergency equipment. See, these are the emergency equipment for, okay. Then you need to note down each load power rating. Here it is given. Then apply the diversity. So here I have not applied the diversity. So as per that 49.7. Okay. Now after that you can see, remember, apply diversity if applicable. Okay, rarely applied. So now if you add the 20% safety margin, so the final emergency load is showing 60 kilowatt. Correct? Is it clear? Now the next is miscellaneous load. What is it and how to calculate? See, all of you, miscellaneous load is what? Miscellaneous load refers to all electrical load that do not fall under the primary category, such as lighting, power, HVAC or emergency. These are often building specific functional load that vary based on occupant type, user requirement and operational activity. Okay, so we have a different types of miscellaneous load. Okay, in office building, you know that we have a server room, pantry equipment, printer, projector, that will comes under miscellaneous load. In hospital, if you see, we have a medical beds with motor function. Okay, lab equipment, that will also comes under miscellaneous load. Even in hotel, if you go, kitchen exhaust fan, elevator, vending machines will comes under miscellaneous load. Okay. In educational building, if you see the projectors, lab instruments, PA system, that will comes under miscellaneous load. Okay. Now here I will show you how to calculate the miscellaneous load, step by step method, same. Here also, first of all, you need to list all equipment device wise. Okay. Then note down the power rating in kilowatt or watt. Then account for quantity and operating hours. Apply the diversity, optional, usually 7 to 90%. Okay. Then include safety margins, 10 to 20%. Okay. So we'll take example. Suppose here we have office pantry, and for this we need to calculate the miscellaneous load. So first of all, what you need to do, you need to list all equipment. So see, equipment is given. Suppose here in office pantry we have a coffee machine, microwave oven, refrigerator and water dispenser. Okay, their quantity is given, rating. First list out all equipment, then note down the power rating. Okay, is it clear? Now see, now total load we have got 4.7. so as I told you, apply diversity, that is optional. 80% we have considered 3.76 kilowatt, and when you add 20% safety margin, the final load is 4.5 kilowatt. Okay, so in this way we need to calculate the miscellaneous load. So now the topics which we have covered in this session, we have discussed in detail about the different types of electrical load. Hope all of you enjoy the session. See you in next one.